In this video, we'll be converting another problem from rectangular coordinates to polar coordinates. Our problem is to convert negative 3i plus 2j to polar coordinates. Now this is vector notation. Our horizontal component is negative 3 and the vertical component is 2. Then we're asked to write 4 forms for the point. Let's draw a sketch of this point. Negative 3, 2 would put us in quadrant 2. Our x value is negative 3, and our y value is 2. To change to polar coordinates, I need to find the value for r and the value for theta. So let's use the Pythagorean theorem to find r. We have 2 squared plus negative 3 squared equals r squared. 4 plus 9, 13 is r squared, so r is the square root of 13 when we square root both sides. Now this is approximately 3.6. Next, let's find theta. We can see that 2 is the side opposite theta, and negative 3 is the side adjacent, so we need to use the tangent function. Tangent theta is equal to opposite, which is 2, over negative 3, which is the adjacent. We need to isolate theta, so the inverse of the tangent function is arctan, or inverse tangent. So we'll inverse tangent both sides of the equation. Inverse tangent tangent are inverse operations, so I end up with just theta. And then we have inverse tangent 2 over negative 3. Make sure you're in degrees. We're showing that right here. And for inverse tangent, we want second tangent. That'll give us our inverse tangent function. And then 2 divided by negative 3. So our calculator gives us theta equals negative 33.69. Now the thing to notice is that negative 33.69 is in quadrant 4. The theta that we're wanting is in quadrant 2. And the reason for this is the calculator will only give values for the angle in quadrants 1 and 4. So what we have to do is add 180 degrees to put it up into quadrant 2. So we add 180. Always make sure that your theta is where you want it to be. So let's add 180 to that value, and we get 146.31. Now this is more like it. The theta value is 146.31, which is in quadrant 2. So one of the forms for our answer is root 13 at 146.31 degrees. Now we're asked to give 4 forms. So if we keep the square root of 13 positive, but change this angle to an equivalent angle, which has a negative measure, I can do that by subtracting 360. 360 is a complete revolution. So negative 213.69. Right now, we can get a negative R value. And for that, we want the vector to be just opposite of where it is in quadrant 2. So we want to either add or subtract 180 degrees from this value. Now if we subtract 180, that'll put us over the 360 degree limit. So let's add 180 to put that in the opposite quadrant. And we get negative 33.69. And then our fourth form is a negative R value. And since this angle is negative, we want a positive angle that's equivalent to this. So we want to do a complete revolution and 360. And we get 326.31.